Okay, guys, welcome to the last robotics and artificial intelligence meetup for 2021. And in today's session, we'll be talking about how to build a walking robot dog from cheap bits. And we have with us the founder of Petoi, Dr. Rongjong Lee, you can call him RZ, and today he'll be sharing his Kickstarter project, which he started as a hobby project and is now doing full time. And after my introductory presentation, I'll just hand over to RZ, and uh, he'll be basically walking us through his journey of how he built this project and also showing us the robot dog. You can ask questions, and the session would be more or less interactive. So if you have any questions or doubts, or if you want to comment on anything, feel free to just do so while the presentation is being done. So you don't need to wait till the end. So we are trying to make it more interactive. And just to quickly point out again, what we are doing here is basically we are trying to learn robotics and artificial intelligence in an active way, which means we take up real world projects, case studies, and over the past few months, we have been trying to invite more and more experts in several aspects of robotics. So hopefully that helps. And anyone can actually share their project. So if you have an interesting project that you would like to share with the community, you can just check the Meetup volunteer channel on the Discord server itself. And the meetings are recorded and shared on YouTube and on the website. So additional resources like GitHub repositories and, for example, the Kickstarter page related to this meetup and all will be shared on the website. So feel free to check that out as well. And this is again some information about some additional roles that you can take and be more active on the server. So here is this is where the meetup resources are shared on the website for every single meetup. So for each of the those 52 meetups, I'm slowly uploading all relevant resources, additional things you can look up, and so on. So now over to you, RZ. So the stage is all yours now. So I'll stop sharing my screen.
Hello, everyone. Can you hear me?
Yeah.
And I'm Rong Zhong, and you can call me RZ, RZ Lee. Um, I'm very glad to share my journey to you today. And I guess maybe you have been enjoying your Christmas holiday. That's why so few people are in this room. But I will present as if I'm presenting to 100 people. Um, so first, introduction of myself. You can see my screen, right?
Mm, yeah, I can see your screen.
Yeah, yeah. Yeah, the most interesting part of my story is I was not majored in in robotics. I was a physics PhD and a computer science master. And after my graduation, I just randomly got the chance to play with Raspberry Pi. And then I realized that programming hardware can be so fun. Yeah, the Pi was really the bridge to connect my software skills and some of my skills trained in my childhood, like I was good at handcrafting, painting, designing, and some instruments. So I think this project, I call it OpenCat, was a very good opportunity to get all my skills combined. And that's why after I started this project, I stopped hunting for a job because I think this can get most of my values out. And so then let's start our journey. So in 2016, I started to build the prototype of this robot. And after 1 year of development, it just got so complex, and I made the decision I need to validate, like whether this project is useful, whether people will need it. Otherwise, I should not keep diving too much into this. We are adults, we have so many responsibilities, and like we have to make a living. So I posted on the Arduino project hub. By that time, I didn't know anything about maker community, or like I was not connected to the outside world. But after the post was made, you can see for all the project hub on Arduino, my project is still the most respected one
Oh wow, I didn't
worldwide.
know that. That's really
Yeah,
cool.
and my second project, Nibo, is also on the top. You can imagine how much feedback from the world I received. Basically, I received invitations of media and customers and distributors asking for this robot. So I know that my work is not just some personal hobby or toy. People really need it, and I should keep on working on it. So I published this project and promised to open source the designs, and actually later I really did. I posted all my code on GitHub. So let me introduce the technology part. Uh, you can see initially the project was the robot was controlled by Arduino and Raspberry Pi. I used the Raspberry Pi to control everything because I was entered this area from a software aspect. I programmed all the basic uh, gates and designed the control logics. But soon I realized that Raspberry Pi was not good enough for this purpose because it's a computer. It has so many threads running at the same time. So if you want your robot to focus on the walking, because walking is a such so precise movement, if it gets interrupted by other threads, you can notice some jigs and shakes in the movement. So later I designed the layer structure, use the Pi just as a brain to make decision position perception and connection, and use the Arduino to do the motion, just the motion, and read the sensors for real-time feedback. The wire structure. Oh, okay. So this was the how the robot looked like as a first effort. It was born on the frame of a helicopter. You can still see it. And I connected the camera, and it just grew and more like a cat with the ice cream sticks. And then I just picked up the 3D printing technology and printed this structure because it allows more complex 3D structure rather than the wood. So at this stage, I really wanted to try to mass produce this. So I made 3 cats. And now I really think it's not that matured to be mass produced. And this was the last prototype. You can see all the history. This one is the end of my efforts as a hobbyist. After that, all I tried to do is to simplify this system to make it cost effective and mass producible so that people can, like, people will not just looking at this post and say, wow, this is so cool, you are very like skillful maker, but it's not really related to them, they cannot enjoy it. So I think the value of my efforts after this was to make this project to be accessible to everyone. So after that, although some technology you may think is simple, but just imagine how hard it is to get it mass produced to solve all the problems in this process. So this is the journey of the start of my journey. And so after that, I moved to Pittsburgh to try to get connected with the local community in robotics because it has a good reputation in robotics, especially for CMU, Carnegie Mellon University. I did make some friends, but I failed to make any official collaboration with the university. So I had to try everything by myself. I found a factory who was supportive to provide me places and equipment as long as I can do some part-time job for them. So during that 3 months, I learned how to operate laser cut machine, how to use Fusion 360 as a modeling software, and designed the first mass-producible version of OpenCAD. It's this Nebo.
So how did you actually come to the realization that people need it and I should start mass producing it?
Because I received so many emails from people,
Okay, okay.
from individuals who wants to buy, and from distributors of a national retailer.
Hmm.
Yeah, and well, I have to admit the most important factor was because I got addicted to the robot. I want to
Ah.
keep on working on it. So as long as I can make a little money to support myself, I'm willing to do it. So
Yeah.
for this yeah, you can see this structure of the cat. Because for mass production, you have um, first to decide which production process you take. Usually, people may take injection molding. It's the most cost-effective way, just inject plastics. But the molds are very expensive. Even for now, like I'm in China, to make a proper mold for this cat, it may cost maybe 50K US dollars. That's a lot for me. I had no money, literally no money at the moment when I started this project. So I decided to use laser cut pieces. It's fast, it's cheap. Um, but the downside was because you build every structure from the 2D structure. When it comes to 3D structure, you have to design some mechanisms. So I actually further extended the efforts to make it more like a puzzle. So the challenge turned out to be an additional value to this robot. People are not only building robots from like the traditional way, like using screws to join everything, but they use the interlocking structure. It's an added layer of fun and learning. So I launched this robot. Oh, you may want to see this. I launched this robot on Indiegogo in 2018, and it was successful. At least I didn't make too much money because the production cost was high, but still I got the initial funding to support me all the way down here. Yeah. So for the next half year, all my time was spent on just making this robot out of the factory. Then I decided I have to return to China because China has the more complete supply chain. Most of my supplies were made from China, and I can reduce the cycle of buying, putting orders and get them delivered to me. And also I can get cheaper laborers and more professional manufacturers to make the pieces for me. Um, so after I returned China, I moved and lived in the factory. Um, on one side is to outsource all the production. They are much cheaper and with even better quality than myself. And second was to design the new robot Beetle. It's here. And I have these two guys in my hand right now. For the robot cat, the problems, as I mentioned, it was made by wood. is too complex to assemble. Even for myself, it may take me 2 hours to fully assemble and tune the structure. And second was because wood is still a little fragile. It may crack if you drop it on the floor. So with the money I earned from the cat robot, I was able to invest into the injection molding. So I redesigned the whole frame to be plastic, more durable, and more polished. And I was able to hide the wires into the structure. So it's a more complete product. I was also able to make a lot of improvements. For example, um, before the cat, users need to buy the battery by themselves. But now I was able to find the manufacturer to design the battery specifically for this robot. It has a charging circuit on site, so you just need a cable. It can charge itself. And for the servos, traditionally servos were not made for like they were just used for driving the direction of model cars or planes. They are not really designed to be a good joint for the robot. And I found a manufacturer who was willing to um, do some research with me and to optimize all the performance. So now the joints can rotate really fast. And for the circuit board, we designed a lot of different versions of board with the help of my friend. Um, like really a lot, maybe 20 or 30 versions. And every version, because we are so close to the supply chain, we can get the prototypes done by like within 5 days.
Oh wow.
5 days, one version. Then we can receive it, test it, and iterate. So with the new board, it's more stable. It's still using the Arduino chip, like Atmega 328P chip, but it has a lot of added features, more stable, more ports. And we also developed this ESP32 board. It's even faster and allow for more logics to be built in the program. Let me find some pictures. Like here, yeah, you can see this. It's not very clear, but basically this is the diagram of the whole structure. You can see that the Arduino sits in the middle. It coordinates all the motions. You know, Arduino is not a very strong chip, so to save the computational power, I pre-calculate the motion behaviors and save them into the memory of this board. And then it will send the joint instructions to the PCA 9685 servo driver. It can split the signal into 16 channels because we have so many joints on the robot. So it can be considered as the spinal cord of the robot. And this Arduino is a little brain. And it has the motion sensor, the body angle sensor, so it knows the direction it's tilting to so it can calculate the adjustment to the static motion. With the static motion plus the feedback, you can get some really lifelike motions. And then the Arduino will communicate with another robot, with another computer, um, so it can receive some high level of instructions, like this one. Oh, you can see the battery is low. And the good thing for this product is I can design the structure to be like easy to install and replace. So if it if it's low of battery, you can easily swap on the battery. Okay. Yes, this is what I mean, the real-time feedback
Ah,
from the body angles. And the board keeps listening to the external instructions. The instructions can be sent from this remote,
okay,
and it can be sent from smartphone apps. It can also be sent from a computer. Like we also support plugging a Raspberry Pi on top of it. So with this structure, like the whole system is layered. Every people with different expertise can join the development. Um, and we published the code to GitHub. Um, and we welcome people to like download the code and also buy our product. Then they can add some new features, like some users may develop a simulator for it or visualization for the postures. Some people design different UI and we share it to try to build a community just like you.
okay. And
And
is there also like URDF models or XML files also available for the model, like in simulation? I mean,
yes, the URDF file is not made by us, but it's made by our users. Um, let me find some demos. Like this one.
also, guys, if you have any questions, you can ask right now. You don't need to wait till the end, right? Feel free to just ask any
Mm-hmm.
questions. Ah, okay. Here.
Yeah. The fun part is um, this simulation is really reproducing the wobbling of the robot.
Okay.
Like it's picking up the imperfection of the gates, and it's just like look like the real thing.
Yeah.
And you can find more video on our channel. Like yesterday, I just finished a revision of the ESP32 board, and you can see how fast this robot can run.
Yeah, I saw this video yesterday. So what was the update that you did? Like before, was it not that fast or
Um, so the project has so many controller boards, as I mentioned, right?
yeah?
This one was the start was the starting point. I learned Arduino at first, and this one is ESP32. It has different libraries and a lot of compatibility issues. Previously, I was so focused on like make sure the production of the robot is good. Now I just got time to polish this code. Basically, is translating the Arduino code to this ESP32 code and try to refactor the code structure. Because previously the Arduino code takes a lot of optimizations because it has very limited coding space. But with the ESP32 board, I was able to write in a more standard format. Like for this main code, you can see the logic is much more clear. Right? It just initialize the like IR receivers, sensors, and initialize the servos, and then it can read commands, read environment signals, and finally perform the skills. I think it's an improvement so that people um, can make modifications to my code
Hmm.
more conveniently. On the contrary, my old code, it has so many tricks, I would say. It just playing so many tricks in the memory, just trying to shrink the complex motion into a tiny Arduino Uno chip. For people like if you don't know how how weak the Arduino Uno is, it has only 2K bytes of SRAM and 32 KB flash. And I just managed to zip everything of this complex motion into the Arduino code. And the downside is it's very hard for people to make any modification to it.
Yeah.
Yeah. Um, Let me see. Oh yeah. And for if you haven't checked, I have this GitHub and I have this documentation center. You can see the user menu of both our robot cat and the robot dog. Although they are designed as product menus, but they are still very technical. You can get a very comprehensive introduction of how the structure is built from the mechanical parts to the wiring
Yeah.
and to the programming. Yeah, you may take a look at the documentation and decide that if you can build it by yourself or if you can just buy the kits from us.
So I'm curious. So the all the parts of it are injection molded. Did you also consider 3D printing, or was that not of an advantage?
So actually, all the parts were initially designed and validated by 3D printing.
Okay.
But the problem is for 3D printing, it's slow and with limited precision.
Ah.
And yeah, and especially for complex structures, the sailing, because you have supporting structures, it's very hard to clean up the internal structure.
So for
So I
mass
just used,
production, mostly for
mhm.
mass production, you would prefer injection molding because you can make manufacture lots of parts in a short amount of time as compared to 3D printing.
Yes. The good part is you can produce them faster with a better structure strength. It won't crack between the layers. It is more polished and it's smoother, especially for the internal structures. The bad part is you cannot make modifications to the structure after the mold is made. So you have to be very careful. And and the cost for the mold is also very high. For example, even before making the mold, you have to use CNC to make a like near finished mold just to validate every part. Just for that part, it will cost about 3K US dollars.
Okay.
So it's a very serious investment. Yeah.
So
And
if anyone has any question right now, maybe we can just quickly pause to see. Lucas, do you have any questions?
yeah, when you are preparing your questions, I will do some live demos for the robot.
Okay.
No, no, from my side, no. I just wrote in the channel. I look into how can I change a little bit from the software to make it dance like Boston Robotics. Let's see if I can do that.
Okay.
Oh yeah, let me go deeper into the code just to explain how it works. Is that okay?
Yeah, sure. Go ahead.
Sounds interesting. Okay. Um, Let me find some some code.
And Manjot, do you have something?
I had no questions, but it was a very interesting.
Okay, okay. So
Okay.
yeah, no questions from your
This
side.
For
is the version for
project.
the ESP32 version. It's very simpler. Um, on the very top, you can consider this robot as a player for animation.
Mm-hmm.
I define the different postures and connect the postures with proper interpolation, and then the robot will perform. Of course, when designing this kind of animation, it's not just drawing the animations. It really considers the balancing and all the physical realities so that the robot can move while keep balancing and keep a good um, dynamic performance, like it can run without falling. So for the postures, I designed like for one poster, I designed one frame of joint angles, and these angles are stored as integers in the memory. And there are also gates, which is a periodical motion. So you can think this is the cool part of the design. If you if you keep calculating the gates, you will cost a lot of computation. But in fact, they are periodical. They are repeating itself. So I just record this cycle and save them as static data. So my chip can be simple. And for the for the program, it can save maybe tens of different skills into the static memory and only pulls up the one is active into the dynamic memory so that you don't need large memory either. Then the chip will just simply loop over the gates, and in the same time, it will read the motion sensor to know how the robot is interacting with the environment, like whether it is tilting, and if it is almost falling, the legs will do some adjustment to stop the trend. So with this combination, static motion plus dynamic adjustment, it makes this robot look so lifelike and have a very good tolerance to the environment. I do calibrate all the joints when assembling, but even I don't, maybe with 5 degrees of tolerance, the robot can still work very well. That's the cool part. You don't have to use very expensive and very precise instruments, and you can achieve this effect. The overall, like the price we sell the robot now is about 250 US dollars. It's much cheaper than the high-end robots.
Yeah.
Yeah, and let me go to the detailed code part to introduce how I designed the gates and other postures. It's in here. Actually, it's here. Okay. For different robots, I define different instincts because they are born with it. Like I'm the creator and they are born with these skills. I store these instincts into the static memory because the static memory I use the EEPROM. They have limited time of erase cycles. Although it may be 1 million times of erase, but still they have limited life cycles. So I only store the static value here. And for the values you have to tune, I call them the new skills, which you just save them in the dynamic memory. If you look at these skills, like for this CRF, which means crawl forward, it first defines how many frames are in the scale. And then these two are the body angles you expect the robot to be, because if the robot is tilted, you will need to subtract the current angle with the expected angles. But for some postures, for example, sitting, it's supposed to be tilted.
Yeah.
That's why I have these two parameters. And the last one is a factor of the angle, because I'm storing these angles with integer, 8-bit integer. The range is from negative 128 to 127. Very limited. If you have large angles, I just increase this factor 2 times. So for a complete skill, it's using very little resources, just 8-bit integer, 36 frames. It's about 500 bytes. You can perform the whole gates, and you can save tens of them in a very tiny chip. And furthermore, to reduce the memory usage, you can notice that for these static postures, it's fine that I store all the joints, like how the head moves, how the tail moves. But for the gates, I only store the movement of the legs, because they are periodical and they have to be very precise to perform walking. But for other joints, like the head, I just bind it to time to generate in real time. In this way, I can save half of the structure here. Imagine if you store the joint of head, joint of legs, and they basically they are not that important, but you will take up a lot of memories. That's the difference.
Yeah.
So you can see how I try to save the cost in both the hardware and in the software. And there's another type of data structure called behavior. It's something between the posture and gait. For gait, you just repeating one walking cycle. And for behavior, it's a connected motion sequences, but it's only performed once. Like for the robot, this is one posture, this is another posture. Between them, they are interpolated to create this smooth transition. And this is walking, this is trotting, they are periodical gaits. But for this one, like greeting, they are connected static postures, but with proper interpolation to create this smooth animation.
And about the behavior that you were saying, so behavior is something different from all of these postures?
It's it's a combination of
Uh,
postures,
okay, okay, okay.
yeah,
Uh,
static postures, and I can add more control sequence, like how many repeating cycles of the postures, and some triggers of the behavior, like the high bar movement is really triggered by certain body angles. And I
okay, got
think I can show you a demo mm, of the beetle. Some really impressive performance. Oh, old battery. Okay. And I can connect to my smartphone app. And this is the control panel. I can control it to stand up and even program some simple postures like move head. Oh, and check. And get ready for this one, back flip. Here, once again. See?
Oh wow.
This is a very high dynamic and a very powerful behavior.
Yeah.
I guess you only have seen it on the MIT Cheetah or some top labs, but we are able to perform these tricks thanks to the lightweight and compact body. Now it's no longer just a dream for people like looking at those fancy movies and say, oh, I want it, but I cannot buy.
Yeah.
We are providing this opportunity. You can put your hands on this little robot.
Wow.
Yeah.
So it's like a very smaller version of Boston Dynamics, Spot, and you can own it, which is amazing. And the good thing is like the cost of it, which you mentioned, right? And so
Yes.
people can actually buy it.
So currently, this robot, we are selling it on Amazon and on our website. We find the most users come from like they are makers, they are engineers, professors, students, and we also have some educational institutes to buy them in batch as their teaching tool.
Oh.
It's very good. Yeah, it's a very good tool. Like the students will have the experience in building the hardware, connecting the circuit, upload code, connect sensors, install the sensors here. Yeah, they can have a complete curriculum to cover a lot of STEM topics. So this the two major markets in for our robot: education and makers phone. And in the future, we are going to add more sensors to make it more intelligent and interactive. So we hope in the future it can also be a good companion robot. Like this, we just install a camera and it's able to track objects. Yeah, this is a backflip. Oh, and it can also be used as some puppet shows. Let me show you this. This is the video we just made for the Christmas.
Yeah.
And oh, this is a complete one. Hmm? I think here. Here it is. And I'm going to show you another movie we just made and haven't released. It's for the new year.
Oh.
Yeah, Brains 2020. So
So for the
with
new year.
relatively cheap price, you are able to program these little robots.
That's really interesting.
Mhm.
Yeah, and I have one question. So many questions actually, but so one question that I have is uh, So for people who want to contribute to your to the code, what is the starting point that you would recommend? Just going directly into the GitHub or your documentation first, or how do you recommend people contribute to this project?
Um, I would think, um, actually, the on average, I don't see many people really build the system from scratch.
Yeah,
I do see some people's posts, like on our website. You can find the forum. I think the first step is just to visit our website, petoy.com, and
yeah.
you can see a lot of media, a lot of documentation, and also this forum. You can see how people play with it and what kind of problems they may meet during their build of the robot. You can get a feeling of the overall difficulty to decide whether you build it by yourself or just buy our kit.
Hmm.
And we have some showcases here. Some modifications are deep, some modifications are simple, like just adding some eyeballs, lights in it,
Yeah.
and building like Lego, OpenCAD. This one is really good. I think he's a very skillful maker. But if you don't have enough time, or if you have limited budget, you may consider buying our robot and just build it following our instructions. Because actually, if you consider all the trials and errors in your building, it's more cost effective just to buy a kit that we can guarantee it can work.
Yeah.
Yeah, but
Interesting.
if you just want to learn and make, it doesn't matter.
That's pretty interesting, yeah. So the yeah, another thing I wanted to ask you is so you did all of the, so there's so many different aspects of robotics involved here, right? So the gate generation, inverse kinematics, forward kinematics, and so lot of stuff, right? And also mechanical engineering and manufacturing, injection molding, all these things. So how did you actually go about teaching yourself so many different fields? Of course it took also few years, right, to and you were doing it on a project, but how did you actually learn all of these things?
Um, First of all, I didn't do everything by myself.
Okay.
For example, the PCB layout is made by my friend,
Hmm.
and the injection molds, they actually get the models from me and they design the injection molds. It's a complete independent, almost independent process. They can control the precision, they can control the material.
Yeah.
Um, and I think the most important part is to keep curiosity, keep curious. Like even before this project, I was interested in many aspects, like physics and computer science are my academic life. I have to learn. But besides, I did got the interest to dive in like digital arts. I take pictures, take videos, which helped me to do the designing of the shape of the robot
Oh.
and have a feeling of what is beautiful, what is neat. Yeah, a lot of this kind of design. And I write poetry, which is playing of words. It is something like fitting a lot of rules in a limited body, like the rhythms, pace of the words, meanings of the words. It's very similar to designing the robot. You have limited uh, the the body. You have limited budgets, costs, restrictions, constraints.
Constraints.
You have to fit everything, right? And I do painting, and I do handcrafting. and I do instruments. All of them, although they look like irrelevant to robotics, but for me, I realized they really helped my like to build all the system and even to build a company.
Oh,
This is the collection of my poems, and this is a playlist of my instruments. Yeah, and after I started to build the company, I feel it's much harder than just the technical part.
yeah.
Now I may only spend one tenth of my time in technology, but more time in managing the company and trying to collaborate different resources and people to move forward to push this robot project forward. Yeah,
Wow.
in
And
my
all these
inside
skills.
is still technician. Yeah,
Yeah, no, I was just saying. So all of these skills kind of helped you in this in the current company right now.
yes. I think the most important part is to keep a open mind, to be willing to learn, and even to change yourself. For myself, maybe 5 years ago, I don't really like business.
Yeah.
Yeah, like I don't respect the businessman. And after I started the project, I know I have to fight for it. I have to learn what businessman thinks so that I can make it happen. So the ultimate goal is not to make money, but to understand how the real world work, how the society work, and how to deal with people.
Oh
That's
wow.
the best part I learned from this project. Not only technical, yeah, but how to deal with people.
That's really that's really inspiring. Thanks for sharing that. Uh, does anyone have anything to uh, say? I mean, if you don't have any questions, so and we're about to just finish it. So, any final words anyone wants to say? I think, like from
Hello.
for me personally, I think it was really wonderful. Thanks for sharing this, and I would also encourage other people to try out the repositories and check out the links and try to actually go into it, because this is something that can be used to learn robotics as well, right? As you mentioned, it's also used in education. So yeah, sorry, someone was going to say something, right?
So I wanted to say that it was a wonderful session, and the bot was like built. The both bots, like cat and dog, were very good. I wanted to ask one question, like how much time did it took for you to means like come up to this stage at to make a final product, like from the initial thought till the product.
Hmm. It's a long journey. I started learning this in 2016, and in 1 year, I iterated 7 times to get the final prototype, the black hat. And after that, I spent 1 year to go to the boot camps for startups to know how to pitch business plan, how to design the business plan and pitch to people, and make up mind to really go into it. And in 2018, I started to work full time on it, and it used me 3 months to build the prototype of the wood cat, and another 6 months to produce, optimize the whole production process as well as selling. And for the robot dog, it was designed at the same time of the cat, but it cost me uh, 3 months to polish, to adjust the original frame, and then 3 months in making the projection mold to and and 2 months to make the campaign page, shoot videos, write the documentations, and so on. Overall, I work 7 days a week and almost 14 hours per day.
Oh my God.
On weekends, I'm like relax a little bit, but it's basically 7 days a week, 14 hours per day for 5 years.
Oh wow. Yeah, that's a lot of work, but you also like the work, right? So that probably helps you. Yeah, you really enjoy this, and it's a cool thing you're building. So you probably
It it
don't mind.
depends.
Yeah, yeah. It
It
depends.
depends on what stage you are in your
Ah,
life.
okay.
For example, uh, I would say I'm really sacrificing a lot of my personal. I'm
Hmm.
still single and I'm
Okay.
living apart from my family.
Ah.
Yeah, so be careful. Consider it seriously whether you can bear the loss when you are gaining some
Yeah, yeah.
progress on your project. Yeah,
Yeah. You have to sacrifice something, right, to make these amazing sort of projects. So
yeah, everything has a price.
yeah, everything has a price. So talking about price, so currently, so is it fully funded by? Is it fully crowd funded just from the Kickstarter campaign, or do you also have some investors, or do you plan to have some other investors in the future?
Um, so for the first campaign, we raised 14, it's 140K US dollars for the cat initially.
Okay.
And we kept selling it. And so far we sold 500K US dollars
Hmm.
from the cat. And for the dog, the initial campaign result was 600K US dollars. And so far we sold 1 million US dollars across all platforms. So we are funded by just selling the product, but we also got angel funding
Okay.
from the founder of a company. Yeah,
Okay. Okay. Yeah, I was just
yeah. I
curious about it.
believe like I prefer to get the funds from our customers
Hmm.
because it validates the value and we can get a really useful feedback from the real market.
Hmm.
We can adjust our directions, not just getting huge amount of investment and try. And then if we fail, I don't feel good to waste money, even it's from the VC.
Yeah, that makes sense. Yeah, that's really fascinating. Thanks a lot for your time today, RZ. So, just one final question, maybe we can quickly take. We are already over time, but one final question from Lucas or Manjot, if you have anything to ask before we wind off.
Nothing from my side. Only
Okay,
good work. Thank you very much.
okay, yeah. Thanks, Lucas, and also I guess not from Manjot either. Okay. Yeah, then thanks a lot, RZ, for your time and for sharing your amazing work. And I wish you all the success for this project, and I hope that it keeps on growing and a lot of people start engaging more with it. And yeah, I wish you a very Merry Christmas and Happy New Year also uh, for next year, and I hope that you keep on doing this amazing work.
Thank you. Thank you everyone for coming. And I know it's holiday time. Enjoy your time.
Thank you.
Cheers, everybody. Bye.
Thank you so